the M18 was faster than anything else on tracks. Factory production on the Hellcat started in 1943. It first saw action in the blazing summer of 1944. Crews loved the M18 for its speed. They also loved its smooth ride, thanks to a state-of-the-art suspension system.
The newest track-laying vehicles, such as the 76mm gun-armored carriage, employs a new system known as torsion bar suspension. The upward movement of the arm twists the torsion bar, and its resistance acts like a spring in supporting the vehicle.
Long after the Hellcat was designed, the U.S. Army's M1 Abrams still relies on a torsion bar system. The swing arms enable this 69-ton monster to travel smoothly at 45 miles per hour. But even all these years later, the Abrams is still not as fast as the M18 Hellcat. Able to cruise at about 53 miles an hour, the Hellcat's speed was legendary, and it had to be. In the final months of the war, 4 M18 Hellcats would play a pivotal role in one of the most important battles of the entire Second World War. When Roger first saw it, the Hellcat was a mess.
They're open top, so they're rusted inside and full of twigs and branches and dust and dirt, so they were pretty dirty. A lot of times they didn't run, so I had a lot of stuff to start with.
Some parts were completely gone. This is where Randy Killen comes in.
I usually get a call. They say that they either have a part that's been rusted out or is actually missing. If it's rusted out, then we'll take it and try to get the dimensions from reference material books, or if we have a duplicate part, we measure that up, we put it into a CAD system.
A lot of the parts are flat pieces of metal because that was the easiest to work with. If you can get a flat piece and weld it to another piece or bolt it to another piece, then you're a lot faster than having to mold it. So a lot of our parts are recreated with flat sheets of steel. Easiest and fastest and most accurate way for us to do that is by using steel cutting laser.
We usually make what we call a soft skin or a cardboard prototype, go back and fit it on the vehicle to make sure that our measurements are correct. We bring it back, do any final changes or adjustments, and then go have it made out of steel or whatever the appropriate material is.
This M18 Hellcat was a ferocious fighter in the liberation of Europe. But the armored vehicle is not exactly what it seems. The M18 is, in fact, a tank destroyer.
The Hellcat is not actually a tank. It's meant to engage other tanks. It's not really meant to engage infantry or support infantry. That's why it has no coaxial gun next to the barrel, nor one in the front hull. It's strictly to kill other tanks.
American tank destroyers were designed to race ahead of an enemy attack. Then, they would lie in wait to ambush oncoming panzers. The M18 was supposed to strike first and then get out fast. A kind of shoot and scoot approach to battle.
We were continuously using the Hellcat as a self-propelled gun. The armament on it with the 76mm cannon was very effective, and the sight on it was such that you could draw a bead on anything up to 2.5 miles distance.
In 1944, the Hellcat's range made it a deadly force in combat. But for today's modern tanks, like the M1 Abrams, that's a mere stone's throw. At the JSMC tank facility in Lima, Ohio, this M1 Abrams is getting its sights aligned. The M1's computer-assisted main gun can knock out enemy tanks over 4,000 yards away.
The M1A2 is probably the most sophisticated tank out in the battlefield. If you think about it as a computer being surrounded by armor, the ballistic computer, basically what it does, it computes any variable. We have a wind sensor, a cant sensor that computer analyzes, and it applies that solution when you fire the round. So let's say, for example, that you were firing on the move, there's lead to be applied, right? Because you're not going to fire where you're aiming. So the ballistic computer applies that lead and then adds the solution for wind, cant, speed, barometric pressure, because the temperature of the round also has implications too. So that's how the ballistic computer works, and it's very fast, and it's what makes the tank as lethal as it is.
The M18 Hellcat was invented specifically to destroy tanks. But war transformed the Hellcat's role, and it was assigned to provide frontline support to the infantry.
This Hellcat is one of the most beautiful vehicles that you could possibly imagine being in combat with. It was just a pleasure to drive them because they had such good traction and speed. A very comfortable ride because it was riding like riding in a boat. A lot of times we were able to convoy infantry on our tanks across the fields that way.
The Hellcat's role change was possible because it had the shooting power to make that switch.
Let me tell you about the gun on the Hellcat. It's the same gun that went on the Sherman. It's a 76.2 millimeter flat trajectory cannon. The real difference was that the tank destroyer crews were issued this hot round, this anti-tank armor-piercing round, and it made the difference to knock out enemy tanks.
When these high-explosive anti-tank rounds slammed into enemy tanks, they would shoot a super-hot jet of molten steel right through the armor. The Germans responded by adding a sacrificial piece of plate armor on their hulls. This extra plate would diffuse the molten jet and protect the underlying armor and the crew. Modern armies have a different kind of tank destroyer. Here, German anti-tank crews use Milan rockets to take out targets over 2 miles away. These rockets operate on a similar idea to the Hellcat's high-explosive anti-tank rounds. But they pack a deadly